Hello, my name is Ashton, and today I'm going to be presenting about the sun for my science project. Firstly, I will introduce our objectives for this presentation. Firstly, it is to learn what is the sun and its lifespan. Secondly, it's understanding the different phenomena of the sun and how it affects our solar system and the earth. And lastly, it's learning the importance of the sun. So what is the sun? Our sun is a star in the center of our solar system. It's a glowing ball of gases made up of almost entirely hydrogen and helium. The sun gets its energy from nuclear fusion. The sun is constantly fusing hydrogen nuclei into helium. The formation of our sun. The sun and the rest of the solar system was formed around 4.5 billion years ago. It was formed when a rotating cloud of gas and dust, called a solar nebula, collapsed and spun into a disk. Most of the material was pulled to the center by gravity, as you can see here, to form our sun. The lifespan of our sun. Currently, our sun is a yellow dwarf, and in about 5 billion years, the sun will run out of hydrogen and transform into a red giant. The red giant will go big enough to engulf Mercury, Venus, and maybe even Earth. The intense heat from the red giant will turn Earth into a hot and dry planet. The sun is a white dwarf. After transforming into a red giant, the sun will start to cool down. The sun will start eating up its helium and release carbon. And when the sun runs out of helium, it will collapse to around the size of Earth, and it will also be much less brighter. The end of the sun. The sun will eventually spend its last days cooling off as a white dwarf until it eventually fades out, as you can see here in this picture. This is what the sun currently is. Okay. The structure of the sun. The sun's atmosphere is made of 3 different parts. We have the corona, which is at the outermost layer, the chromosphere, and then the photosphere. The sun is also made up of 3 layers. The outermost layer is the convection zone. Second, we have the radiation zone, and in the innermost layer is the core. The characteristics of each layer of the sun. The convection zone. It's the 3rd layer. It's where hot gases expand and rises and then plunges back downwards. The transfer of heat here also occurs more rapidly compared to radiation. Radiation zone is the 2nd layer. Energy is primarily transported through radiative diffusion and thermal conduction. And lastly, we have the core. It's also the innermost layer. It's also the hottest part of the sun, where temperatures reach 15 million degrees Celsius. It's also where hydrogen combines to form helium. Here are a few examples of phenomena that occur on the surface of the sun. We have granules, sunspots, solar cycles, prominences, solar flares, coronal mass ejections, and solar winds. So what are granules? Granules appear as grainy structures on the photosphere. Granules are caused by the current and movement of plasma in the convection zone. Here we have sunspots. Sunspots are dark regions on the surface of the sun. They appear dark because they are colder than the surrounding areas. Sunspots are formed in areas where magnetic fields are strong. They always exist in pairs or groups. Now I will explain about solar cycles. What are solar cycles? Solar cycles are the cycles that the sun's magnetic field go through every 11 years. Every 11 years, our sun's magnetic field completely flips. North and South Pole becomes South and North Pole. The solar cycles affect the activity on the sun, such as sunspots. The beginning of the solar cycle has the least amount of sunspots, while the middle has the most. Next, we will learn about solar prominence. Solar prominence is a huge loop of bright glowing gases, plasma, extending outwards from the corona, Prominences usually last for several days to several months, and they can reach as big as the size of Jupiter. Next we have solar flares. Solar flares are sudden explosions of bright energy that releases a lot of radiation into the space. They often occur near sunspots. If the solar flare is very intense, the radiation released can interfere with Earth's radio communication. The charged particles from the solar flare can also collide with the atoms in Earth's atmosphere to cause auroras. Besides that, we have coronal mass ejections, also known as CMEs. CMEs are large explosions of plasma and magnetic field at high speeds from the sun's corona. They often occur along with solar flares. CMEs can also produce auroras if their charged particles collide with Earth's atmosphere. As you can see here, CMEs appear like an expanding cloud. Next, we will learn about the importance of the sun. The sun has a lot of importances to Earth and humans. One of them is photosynthesis. Without the sun, photosynthesis cannot be performed by plants. Photosynthesis is the process in which plants use sunlight, water, and carbon dioxide to make energy. In this process, oxygen is released by the plant. Without the sun, photosynthesis cannot occur, and because of this, oxygen cannot release, and oxygen is what makes life possible on this planet. So without the sun, all life on Earth will probably go extinct. Next, the sun also has a lot of benefits to humans. The sunlight from the sun can help you feel more calm and less stressed by helping your brain to release hormones called serotonin. Exposure from sunlight can also provide vitamin D for the body. Vitamin D can help strengthen the immune system to fight off infections. The sun can also be used as a source of energy. The sun provides heat and light to Earth. It warms our oceans and enriches our soils. We can also harness the light from the sun to be used as a renewable source of energy by using solar panels. Solar panels work by allowing photons from the sun's light to knock electrons from the protons to generate electricity. That's all. Thank you for listening to my presentation.